So now we are discussing fourth question, which appeared in Lead Code Weekly Contest 374. So the question is, count the number of infection sequences. Basically, we are given an integer n, and we have to consider a zero-based indexing, an array zero, which is zero-based indexed and sorted in an increasing order. In the array, we are given positions, which represents the children which are infected at those positions. For example, in the first input, it's given 0 and 4. So 0 and 4th child are infected. Now, as the question proceeds, it is given that infection at each second, only one child can be infected. At most, one child can be infected. And the person who is infected can pass the infection either to its left neighbor or to right neighbor. So we are asked to determine total number of sequences, to total number of ways in which the infection can spread to all of the children. Now, since the answer might be very large, so we need to return it by dividing it by 10 to the power 9 plus 7.
We need to return the modulus value.
Modulus value.
After division.
Yeah. So let's get a clearer view of the first input, which is given to us. So this is the first input which is given to us. So in that index, in that input, we are given array as 0, 4. This is our array given initially. So as discussed in the question, the positions could be 0, 1, 2, 3, 4. Now 0 and 4 are infected initially. We need to find out how in how many ways all the children from 0 to 4 can get infected. And at each second, at most one child can get infected. So the ways could be, first the infection can go from 0 to 1, then 1 to 2, and then 1 to 3. So this is a way, 1, 2, 3, as written here. So similarly, another way could be, first the infection passes from 0 to 1, then the infection passes from 4 to 3, and both of them passes the infection to 2. This is the second way. Another way could be that infection passes from 4 to 3, then 3 to 1, and then 2 to 1. This is the third way. And the last possible way could be, first the infection passes from 4 to 3, then 0 to 1, and then both of them pass it to 2. Since 2 is not the neighbor of any of the initially infected children, so it can't get infected initially. So this was the question. Now look up for the solution.
So let's look at the constraints of this question. So the n value is from 2 to 10 power 5. The sick length is from 1 to n minus 1, which means there's at least one person sick, and there has to be at least one person who is not sick, right? And this value ranges from 0 to n minus 1. So basically, all the sick people are in a sorted order, and their positions are 0 index, right? Now, let's break this question down into simpler chunks. Okay. Let's take the basic example in the given test case. Let's say I represent the infected person with I. So this is 0th position, 1, 2, 3, and 4. All right. Now we found out from the sample test case that the possible test cases are 1, 2, 3, 1, 3, 2, 3, 2, 1, and 3, 1, 2. Right. And the infection passes at every second, only one extra person can get infected, right? So if you look at this, now in this case, we have one subarray of uninfected people bound by 2 infected people, right? So let's try to observe a pattern in this. Let's take a smaller example. So we know for this the answer is 4. So let's say there is only one uninfected person bound between 2 infected people. So there is only one way for this. This person gets infected because there is only one person. The number of ways is 1. Now for this, what are the number of ways? Either 0, 1, 2, 3, right? Either 1 gets infected first, then 2, or 2 gets, then 1. So there will be total 2 possibilities in this scenario. All right. So that is 2. For 3 people in the middle, we'll have how many possibilities? as we mentioned, saw here, it's 4, right? So if you observe, there is like a power of 2 pattern. So in case if we had 4 people in between, the answer would be 8, right? Now let's understand how we can conclude this. So basically, let's say if you're moving from 3 people to 4 people uninfected, what happens in that scenario? We already have the answer for what if 3 people get infected, right? So this answer is 4. Now this extra 1 person, either he can get infected from this side. In that case, there will be a whole new set of subsequences, or he can get infected from this side. In that case, there will be a whole new set of. So 2 sides, so 4 into 2, which will give you 8. And see, so basically the same thing will happen. So once we have the answer for the first one, like a base case, we can just extend it and find the answer for the other ones, right? So that one pattern we can observe basically. So if there is a set of uninfected people bounded between 2 infected people, we know the number of possibilities of arranging them in sequences. Okay. Now let's see another scenario. All right. Let's say there is one infected people. Let's say 5, 6. Let's say 5 uninfected people, and there is nothing after this. Okay, this is the end of the array. All right. In this scenario, there's only one possibility because we can always move ahead, yes. Right? This person gets infected, only then this can get infected, only then this can get infected. So there'll always be only one possibility in such a scenario. Even for the beginning of the array, okay, if there are 5 people in the between, this infection will go backwards. So in this case also, there'll only be one possibility, right? Now that we have the values, now that we have considered these 2 possibilities, let's take an example case and let's try to break it down into these 2 cases. All right. So this is the case number 1 and this is the case number 2. All right. Basically, I'm including these both in the same case because it's the same thing, just reverse. This is for the ending, this is for the beginning. All right. Now let's take a case. Let's say we have 2 people, then 1 infected person, 3 people, 1 infected person, 3 people, 1 infected person, and 2 people. All right. Let's say there's a case like this. So here we know that the number of possibilities for this is 1. Right? For this is 1. For this, the number of possibilities will be from the pattern we have observed, it's 4. Right? So basically, okay, we can convert this into a simple formula. If we have 3 people, our answer is 4. So what can the formula be? 2 power n minus 1, basically. So if n value is 3, we get 2 power n minus 1, which is 2 power 3 minus 1, which is 4, right? Similarly, here 2 power n minus 1, which will again give me 4. And this is a ending scenario, so it will be 1 no matter how long this length is, right? Now we know that there are 4 different ways of arranging this into sequences, 4 different ways for this. Only 1 in this and only 1 in this. Now, a question is, how can we combine these into a final result, right? Now, let me take a smaller test case to explain this scenario. Let me just consider this chunk, for instance, this chunk as a test case. So let's say we have infected person, C uninfected, then infected, C uninfected, and an infected. All right. So for this, the answer is 4. For this, the number of sequences 4, right? Now,
so these answers are for individual.
Yeah.
Part of portion
Yeah,
of the
this is for the individual. So this is like assuming only this is one a separate case,
Yes.
test case, and this is assuming there is one separate test case. So now we want to think about how we can combine these.
Combine them and get right? The final answer.
Now, what is the general idea for combining? Our first thought is we can just multiply them and maybe that will combine and give us the answer. But okay, let's see how that works out. So let's do one thing. We'll just write the index value 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. Now for the first 3, the cases are 1, 2, 3, 1, 3, 2, 3, 2, 1, 3, 1, 2, right? And for this second, we have 5, 6, 7, 5, 7, 6, 7, 6, 5, and 7, 5, 6, right? So there are 4 cases here, 4 cases here, right? Basically, if we combine them, what I'm suggesting is we combine like this, right? Something like this.
So basically, we are doing one-to-many mapping.
One-to-many mapping, right? So for every one of these sequences, we are mapping it to every other sequence, right? So in that way, we can easily say that there are 16 combinations, right? But is it really the correct answer? Let's see. Now, let's say I'm taking a mapping between 1, 2, 3 and 5, 6, 7. All right. Let's take one of them. 1, 2, 3, 5, 6, 7. Okay. Now that 1, 2, 3, 5, 6, 7 mapping is only one time existing, right? So let's see, can we form more sequences based on these patterns? So we can basically have 1, 2, 3, 5, 6, 7, or we can have 1, 5, 6, 2, 3, 7 also. There is also one possibility, right? We can also have like 1, 2, 5, 6, 3, 7, right? So basically, when we intermix these two, so basically what I'm suggesting is when we pick up any one-to-one mapping out of these, even in that we have multiple scenarios, right? So now this is the part where the question becomes a little complex, okay? Now let's see in how many ways we can mix these both, all right? So basically, uh, after mixing the total length will be what? Total length will be 6, right? Total length of the sequence. So 1, 2, 3, 4, 5, 6, right? Total length will be 6. Now, to find the number of possibilities, I basically fix 1, 2, 3. So in how many ways in 6 positions can I put 1, 2, 3? It will be 63, right?
Yeah.
So I can put 1, 2, 3 in this entire grid in 63 ways, right?
Yes.
Let's say I put 1, 2, 3 here. Okay. Now this remaining 5, 6, 7 will have only one way of going, right? Because they have to be in order.
Yes, sir.
We cannot mess up the 5, 6, 7. I mean, this is considering one of the cases, right? So after we fix 1, 2, 3, the 5, 6, 7 will go in the remaining places. So basically, for mixing these two sequences, we need 63 ways, right? But let's come up with a generalized formula, right? So if I consider this as M, if I consider this as N, the total number of places will be how much?
M plus N C M.
M plus N. And the number of ways we want to arrange one of them is this. M plus C N. Alright. Now this is the same as M plus N C N. Because if you fix this and put this in the remaining places, or fix this and put this in the remaining places, the answer will be the same. Right. So we can take either one of them. The M plus C M. Right. Now here we had M and N value both were 3. So our answer in this case was 63. But in case if it was like
say 6 and 2.
Yeah, let's say it was here, we had only 5 and 6. In that case, M plus N will be what? 5, 3,
2 or 3, both will work.
2 or 3, right? Both will work. So yeah. Now, this answer, let's just write the generalized formula again. This answer, N plus N, C N, this generalized answer, this applies for the number of possibilities within one of the mappings, right?
Yes.
Which means these mappings will exist.
Yes.
But on the top of that, in each mapping, there are M plus N, C N ways, right?
Yes.
Considering this is M and this is N. Okay. So now we have ourselves like a little bit like a formula, right? So basically, so in this scenario, our total number of possibilities will be what? It will be 4 into 4 into 63, right? Now, what is actually happening? 63 is basically m plus n cn, right? And from where are we getting 4 and 4? Now, here 4 is basically the number of possibilities of arranging this first part, this 1 to 3 segment. And this another 4 is the number of possibilities of arranging this part. So basically, it's like if this is P1, P2, it's like P1 into P2 into m plus n Cn. All right. This is our generalized formula, right? Where P1 indicates the number of possibilities of arranging this part, P2 indicates the number of possibilities of arranging this part, M and N are the lengths.
So firstly, what we are doing is we are breaking the array which is given to us into smaller parts.
Yeah.
And then again we are rearranging the parts which we got by breaking them.
Yeah.
And finding the possible combinations of positions.
So basically, for every possibility, for every part that we break it down into, we find the number of possibilities of that part. And when we want to combine, we multiply those possibilities, and we also find out if we multiply one possibility, how many extra will there?
Yeah. In how many ways they can also be rearranged.
They can also be rearranged. Right. So yeah, let's go back to this test case, and let's draw it down here. Okay. Now I'll not deal with actual numbers because the answer may get very huge. So let's say this is the test case we initially considered. Now here we found out that number of possibilities here are 1. Here there are okay. Did I take 3? Okay, let's take 3 instead because 2 will be very small. Let's take 3. So yeah, there'll be 4 ways here, or let's say for diversity, let's take yeah. So 2 ways here and 1 way here, right? This is the ending, so there is 1 way. This is the starting, so there is 1 way. This has 3 uninfected people, so 4 ways, and 2 uninfected people, so 2 ways, right? Now let's see how we can combine this. Okay. Now the way we combine this will be very similar to the way we combine while doing modulo arithmetic, right? The way we combine the answers for modulo arithmetic. So basically, we combine the answers for 1 and 4, and whatever the answer we get for this, we combine that with this one. So we combine the first two, use that answer and
to combine with the third one.
To combine with the third.
That to combine with the fourth one.
And use that to combine with the fourth one, and we keep doing that, right? So yeah, let's see how that turns out to be. Now here we have 1 possibility here and 4 possibilities here, right? So firstly, we combine these 4. So 1 into 4 will give us our answer 4 into. Now we want to find
the combinations between them.
Right? So this is n, which is 2, length 2. This is length 3. So 5 plus 2 plus 3 will be what? 5. 5C2. Right? 5C2. We have 5C2. So 5C2 will basically be 10, and this is 4, so 40. Right? Now let's write a new thing. Now for this entire part, the number of possibilities are 40. Right? And the new length will basically be the addition of these both. So instead of writing 2 and 3, we can just write 5. Right? So basically, this is like a length 5, and the number of possibilities are 40.
So it's a takeaway from here that when we are moving to the second part, so with the possibilities that we get, which is 40 here, we also have to change the length. Like we will be
we have to change the length. Right.
Now we
because
will,
next time when we multiply the next one with the previous
Yeah.
possibilities,
so we will
we need
multiply
to
with
take
the
the
whole
combined
array,
whole
whole previous array.
previous length.
So length needs to be changed here.
Length needs to be changed every time.
Okay.
So now we have 4 and 40 and 20, 40 and 2. So 40 possibilities into 2 possibilities into. Now, when if we combine this together, this is of length 5, this is of length 2, right? So m value is 5, n value is 2, 5 plus 7 is 5 plus 2 is 7. So 7c2, right? And yeah, let's say this is some value x. Okay. Now let's not get down into calculations. Okay. Let's say this is some value x. Now, now that we have found that for x, what we can do is we can say that okay, the number of possibilities here is x,
And the length changes
and the
to 7.
updated length will be
7.
7.
5 plus 2.
Okay, and this is 2, length 2 here. Okay. Now we have x value. We say that this is one possibility here. So basically x into 1 into 7 plus 2, m is
Yes.
7, n is 2. So 7 plus 2 is
9c2.
9, 9c2. 9c2, right? So whatever that will give us the actual answer for this entire question. So yeah, basically what we have to do is we also have to perform the modular arithmetic operation. So
At each step we can perform it. So that the
at
answer
each step we need to perform it.
don't go out of bound.
Exactly. So the answer does not exceed 10 power 9 plus 7. At every step, whenever we do multiplication, before that you perform this operation, after that you perform the operation to ensure that the answer does not exceed this value. Okay. Let's just say what the prerequisites for this question are, because I didn't mention them. Basically, if you have to solve this question, you need to know multiple things. One thing is you need to know to calculate mod inverse, right? Because mod inverse will be required for our calculation of NCR.
Yes.
This will be helpful when we calculate NCR. So for NCR, we have a algorithm called Fermat's-Little theorem. So with Fermat's-Little theorem, you can find out the value of NCR modulus some prime number. In this case, it's 10 power 9 plus 7 in a very efficient way. So if you go by the standard method and multiply and try to divide it, that will not give us the correct answer because it will make it complicated. Basically, we have to know mod inverse, we have to know how to find out NCR efficiently. Another thing is we need to know some basics of combinatorics. Right? Some basics of combinatorics. And yeah, I guess that's about it for the prerequisites that are necessary. So if you find this video confusing, that's all right. It's better to learn these topics first and then come to this question because these concepts are like little part play a little role in the solving the question. So if you're not clear with these topics, then understanding the question will become very difficult.
Also, the calculation might give you the wrong even after performing all these correct operations.
Exactly. So yeah, so the calculation might give you wrong answer if you don't know the right way of performing all of these, right? So yeah, let's discuss the time complexity for this question. So time complexity will be O of n only because we are just moving forward simply, and at every point we are identifying how many groups are there, what is their length, and at every point we are combining the results, right? So here at every point we combine the results of the we found until that infected point, and then use that to combine it with the next infected point, right? So the time complexity will be O of n.
So what like we are calculating NCR here. So
yeah.
What will be its time complexity like that theorem you mentioned?
Okay, so the time complexity for finding NCR will be just O of 1 only, because Fermat's little theorem is a very efficient way of calculating it. Okay. I mean, for finding NCR, it will be O of n, but for finding NCR, we also need to know the modulus inverse value. Modulus inverse value will have a complexity of O of log n. Okay. For a given number n, it takes us log n time, because we'll be performing binary exponentiation, right? So, okay, that actually we can include as one prerequisite also. We need to know binary exponentiation, and we also need to know pre-computation. Okay, so basically, when we find out NCR, the formula for NCR will require n factorial by n minus r factorial into r factorial, right? So we cannot calculate the factorial values every single time, right? So we basically have to pre-compute them before we go through the test cases, right? So pre-compute all the factorial values, and then you can find mod inverse of those pre-computed factorial values, and yeah, NCR and basic combinatorics, binary exponentiation, all this will be required for this question. Let's see the space complexity. Now we could store all these values one by one in an array-like thing, but that is not really necessary. I mean, at every point we can just keep track of two different values. So the number of possibilities and the size of the array, right? The number of possibilities previously encountered and the size of the array. And every time we take another sequence into consideration, we use these previous values and update those values, right?
So the work will be done with two variables only.
Two variables.
No extra space is required.
No extra space will be required. So we can just say this is O of 1. But for pre-computation will require space. So I'm sorry. Yeah. So pre-computation will require some space, and we need to find factorial values up to 10 power 5. So the constraints are up to 10 power 5, right?
Yeah, they were up to 10 to the power.
So okay, yeah. Space complexity will also be O of n, because n value can be up to 10 power 5, and we need to pre-compute those factorial values. Right. All right.